We are done with univariate analysis. Now let's move on to bivariate analysis. Bi means two variables. Now our target variable is stroke. By bivariate analysis, what I mean to say is every factor that we have, what is its impact on the stroke? Let us suppose marital status. Does it impact stroke? Gender. Does it impact stroke? Residence, rural versus urban. Does it impact stroke? BMI, heart disease, previous heart disease. BP, average glucose level. What is their impact on stroke? Earlier, we have analyzed all these variables individually, independently, one by one. Then we found some factors. Now we want to see their impact on the target. That is known as bivariate analysis. Let us do some bivariate analysis. We want to see the relationship between these variables versus stroke. Let us see one example here to understand. So let us start with bivariate analysis. Let us start with first measure, let's say risk factor 1. Now this risk factor 1 versus stroke. Does it have this risk factor 1? Does it have any impact on the stroke? So let's take stroke variable. So do not summarize by stroke. Create a cross tab. In a cross tab, you have rows and columns. So instead of this table, create a matrix, convert it into a matrix. You can have either rows as risk factor or you can have columns as risk factor. To be consistent, what we will do is we will take stroke as 0 or 1 and risk factor is on the column which is 0 or 1. First of all, we have to format this table to make it look better. So as usual, make it somewhat like 13 or 14, 13, and the column headers also make it like 13 or 14. Okay. And then if you want to make it little beautiful, then go to style presets, maybe flashy rows. Okay. This is the one that we have created. Now what you can do is you go to this table. In the values, just simply take the ID. Okay. Count of ID. Count of ID. Yeah. So people who got stroke denoted by 1. High risk factor, high age, 206. Out of 249 people, 206 are from high age itself. 249 people got stroke. Out of them, 206 are from high risk age. 249 people got stroke, only 43 are from this bin, which means this particular variable. Okay. Out of 249 people, a lot of people are from high risk age. Definitely, there is a lot of impact by this particular variable on stroke. Now, instead of seeing counts, it's better to see percentages. Let us see how to convert this into percentages. Okay. So click on these values, show as percentage in row, show as, display it as, show value as percentage of the row total. So out of 100% of the people who got stroke, 82% are from one category only. Which category? That is from high risk age category. So definitely, actually, if everything is fine out of 100%, only 33% are from high age. So that means it should be 33%. But instead of 33%, 82% are from this category. For example, I'll tell you an example. If there are 100 patients, out of them 33 are of high age, 33.1%. That means overall I'm talking about 33 are of high age. But a lot of them are having stroke. Out of 100 people, almost 82%, 82 people are getting stroke if they are from this category. Definitely a person having high age, this risk factor is definitely a very highly impactful factor. That is one way to analyze the variable versus the target stroke. In fact, you can also take a column called stacked column chart. or any type of chart you can create. Let us create one more diagram for this stacked column chart. Okay. In this one, select x-axis as our high risk age or risk factor one, and then y-axis is count of IDs, isn't it? Count of IDs, and then legend. Our legend is a person has stroke or not. Okay. Now, if you see that, okay, we can modify this color as well, but that modifications and all that we can get into it later. Okay, if it is quick, we can modify it quickly here itself. Visuals, x-axis, legend, and then where is the color? Columns. Select the second color as, let me say, to make it appear little flashy. We will try to choose this color, or let me choose this color. This goes well with this. Okay. So this is the high risk age. A lot of them are having stroke. There is a higher percentage, though overall these are lesser in number. This high risk age, there are less people, but a lot of them got stroke. So definitely there is a high impact of this variable. Okay. That is the risk factor one versus stroke. Similarly, we can play with other variables as well. Let us see stroke versus gender. I'll show you an example where it is independent when there is no relationship. So let us take gender. Okay. Let's take this column only, this particular one. Here, instead of risk factor, let me take gender. Okay. And here also, instead of risk factor, let me take gender. Now look at this, all of you. Let us analyze this. Overall, there are 58% female, 41% male are there. 58, 41. Okay. Almost nearly 59% female, 41% male. So if you see all the people who got stroke, 53% are female, 42% are male. So overall, the percentage is almost same. So how many ever female are there out of the people who got stroke? Out of them, those many are female. Out of the people, how many ever male are there in the whole population? Out of the people who got stroke, they're also male. So if you look at this percentage of this orange color in this one and this one, there is no significant difference. Proportionally, almost they are same. So I can say that gender has no huge difference. People who got stroke, same percentage are there in female as well as male. If you look at the overall percentage, almost male and female are same. Okay. So I would say gender has no huge impact on your target, which is stroke, whereas age factor, risk factor one has very huge impact. If they are from this category, then there is a high chance that they will get stroke. Okay. There is one more way of performing your bivariate analysis. First, complete this. Okay. There is an easier way. Not every time you have to create visualizations like this. As I tell you, data visualization is not really about creating very, very attractive, beautiful visualizations all the time. That's a mistake that people do. You have to derive insights out of it. How do you get the insights? Try to focus on those insights. Okay. So there is another way of getting the insights. Okay. Let us see how to get those insights. So what you can do is you can create a binary table. Okay. Then let us take risk factor one in that, risk factor one, and then simply look at the stroke rate. Okay. There is a variable called stroke rate. Risk factor one, stroke rate. Let me improve this column. Let's do one thing. Let's ignore this and let me copy paste this one so that I don't need to reformat it. So let me put it here. And then here, instead of stroke, I will take stroke rate. Let us take rows as this one and columns as stroke rate. Values as stroke rate. either this one or this one, any one of them is fine. So if you look at that, let's make it little bigger. Shall we use any style presets? No. Column headers, row headers. Maybe let's make it slightly bigger, 13. Make it 14. Yeah, row headers. And then column headers, 14. Values also 14. Yep. So this looks good to read. Now what you can do is, what you can see is when the age is high, risk factor is in this category, then stroke rate is high. Okay. When low risk age, okay, when they are in this category, when age is less, then the stroke rate is less. So you can simply show that, or if you really want to show any visualization, you can do something called conditional formatting. Okay. So click on this stroke rate and check conditional formatting. Background color or font color, data bars or icons. So icons are easy to identify. Okay. So what you can say is the icons are red, orange, green, either this way, or we can reverse it because we want higher stroke rate means that is a danger sign. So let's make it red. Reverse this order. That will be green, amber, red. Okay. So you see that this is higher stroke rate, this is lower stroke rate. Okay. Maybe I'll ignore the background colors in the rough styles presets. I'll go to, instead of flashy rows, I'll take sparse one now. Minimal. Yeah, that would do. So here is the place where there is high chance for a stroke. What I'll do is now I'll quickly create for other variables as well. Do you think gender has any information related to stroke? So get gender and put it here, keep everything same. Female, male doesn't really differ. NA and other, you can ignore them for now. Okay. Control C, Control V. And then do you think your residence type? Let us go to residence type now instead of gender. What if I choose residence type? Residence type also rural, urban is almost same. No need to worry about that. Okay. The next one is risk factor 2. Let us see whether you people have this risk factor. High risk factor. Yes, this is high risk. Automatically, we are saying higher stroke rate here. That means risk factor 2 is connected to, I think, heart disease or something. If somebody has heart disease, then they are at a higher risk. Then go to work type. Do you think work type has anything to do? You can very quickly create and find out the impact. Children, government job, never worked, private job, self-employed. Work type doesn't really have any impact on stroke. Almost everybody have the same stroke rate. I mean, when can I say they have the same stroke rate? Look at this, female and male, they have almost the same stroke rate. So that means I would say gender has no impact on the stroke. Then go to the second table here. The second table has heart disease. Okay. Whether heart disease has any impact on this one. Yes, when heart disease is present, then there is a high chance for stroke. When there is no heart disease, 4.1%. But when there is heart disease, 17%. Now that is high. Okay. Let me also put one more. Smoking. Does it have any impact? Smoking versus smoking status versus stroke. Smoking status versus stroke. Formerly smoked, they have higher risk. Never smoked, obviously lesser. Smokes, this is surprising. People who smoke, there the stroke probability is lesser. But formerly smoked, they have higher stroke. Unknown is 3%. Okay. And then is there anything else that is missing? Hypertension, when people have BP, does it really impact your stroke chances? Let us check. Let me put it here. I'm just arranging. I'm trying to make sure that everything is on one page because we are just doing the exploration here. We are not really finalizing these reports. We are not really publishing these. We are not sending these to client. We are actually right now identifying what are the impactful factors on stroke. So the last one is whether they have hypertension or not. That means BP is there or not. If I put hypertension here, people who have hypertension, yes, they have very high chance of stroke compared to people who do not have hypertension. Can you now see and tell me what are the variables that are having impact on stroke? The variables that have huge impact on stroke are, what are they? Hypertension, like start from here, risk factor 1, which is like people with higher age. Gender doesn't have any impact, residence type doesn't have any impact. Risk factor 2 definitely has some impact. What is that risk factor 2 connected to? Heart disease. Heart disease has definitely an impact. And then hypertension has an impact on stroke. So definitely these are the variables that are impactful on the target variable, which is stroke. Have you understood this conditional formatting? Once again, how do you do that conditional formatting? Let us suppose if I want to do a different type of conditional formatting. First, remove conditional formatting. Okay. Now here in this table, I'm doing a different type of conditional formatting. Conditional formatting, maybe this time I want to put data bars here. Data bars, show bar only. Okay. Left to right. Yep. Okay. Check that out. If I want to show value as well as bar, okay. Remove conditional formatting, all conditional formatting, conditional formatting. I want to put data bars here. Okay. How does that data bars look like? Are they looking better? Data bars are looking better, or these icons are looking better? You can put whatever makes it look good. Okay. If you feel these data bars are looking better, we can keep data bars. In fact, in conditional formatting, the advantage is you can put both of them. Let's say if you go here, if you want to add another conditional formatting, that is also fine. You can put data bars as well as this one. Okay. So that you can ask people to focus on this red as well as the bar is also showing that, but both of them may not be required all the time. Now that is categorical discrete variables versus target. Now there are continuous variables. What are the continuous variables? Age versus stroke we haven't seen. BMI versus stroke we haven't seen. Average glucose level versus stroke we haven't seen. So how do you do continuous versus stroke? This is bivariate analysis. We started here. So let me rename this as bivariate analysis 1, bivariate analysis 2, bivariate analysis 2. This is bivariate analysis 3. All right. Now bivariate analysis 4. Bivariate analysis 4. Let us take, how do you analyze average glucose level versus stroke? So for that, what you need to do is, as usual, table, take the table from the previous one, maybe this one, you take it and then paste it here. And here you take stroke. Don't take stroke rate, take stroke, which is 10, and then take the average of age, okay, in the columns. Instead of age, you summarize it, okay. You summarize this, you put it in values, that would be better. Values, instead of sum, put it as average. Check this out. Average age, when people are having stroke, what is their average age? 67. When somebody doesn't have stroke, what is their average age? 41. If you want to do conditional formatting, here also you can do show value as, or where is that conditional formatting? You can put data bars if you like to, or you can put that type of conditional formatting as well. Okay. So data bars are different. When age is high, then there is, when stroke is there, then in them the age is high. People without stroke, their age is lesser. So that way, if there is a significant difference between people with stroke, without stroke in their average age, what is the second variable? Average glucose level. Put it in the values instead of sum, make it as average. You see this result. What does this result say? This tells us that people with stroke, their average glucose level is higher. People without stroke, their average glucose level is lower than the average, overall average. Overall average of glucose level is 105. People without stroke, their glucose level is lesser. The third one is BMI. So if I include BMI instead of sum, again, you have to take average here. Look at this. Average BMI is 28. People with stroke, without stroke, almost same BMI. For me, I would say BMI doesn't have huge impact. Even glucose level also doesn't have huge impact, but age is very high compared to the people or the patients without stroke. With stroke, there is a difference for sure. Okay. That is how you can do the bivariate analysis. Bivariate analysis is every variable versus target. It is not necessary that you have to do this type of analysis only. Any other intuitive method, any other way of extracting the results, somehow showing the relationship between this variable and target. Somehow, if you can bring hidden patterns, that is important. Bringing hidden patterns. Okay. If you can somehow bring the hidden patterns, that is perfectly fine. That's the bivariate analysis. What is next? Next is multivariate analysis. What do you mean by multivariate analysis? Multiple variables. Multiple variables versus target. If age is in this band, if person has heart disease, if BMI is in this band, does it impact stroke? Two, three variables put together. If variable 1 takes this value, variable 2 takes this value, variable 3 this takes this value, variable 4 takes this value, if their customer falls into this segment, there is a high chance for him to get stroke. Now, this is the ultimate final result that we are looking for. What kind of patients are most prone to get stroke? What kind of patients are very, very less prone to get stroke? That will be our ultimate final finding that we want to give. That is multivariate analysis. That is our next step. So let us get into multivariate analysis. But before that, complete all these tasks, complete all these findings before getting into multivariate analysis. I'll see you on the other side.